Good afternoon, everyone. This is M. Shireesha, working as an assistant professor in CSE department in BVRIT, Narsapur. Today, I want to explain a topic from compiler design subject. In this compiler design subject, just I want to explain about what is a bottom-up parser. Okay, when we are going for the parser will be generated by using syntax analyzer phase. Okay, here the syntax analyzer phase is also called as a parser. Why it is called as parser? Because it is going to generate the parse tree representation as an output. Okay, when it is going to take the number of tokens as input, it is going to give the hierarchical representation of the tokens. That hierarchical representation is here, it is called as a parse tree. When we are going for the parse tree representation, we are having two different types of parsers. One is top-down parser and the other one is bottom-up parser. In bottom-up parser, we are having how we are going to reduce a given input to the starting symbol of the grammar. When we are discussing about top-down parser, we are expanding the root, nothing but the starting symbol of the grammar to the input symbol. Whereas when we are going to the bottom-up parser, just we are reducing, we are taking the input string and how we are reducing it to the starting symbol of the grammar. Okay, this is mainly how we are going to generate the parse tree representation by using bottom-up parser. Okay, and in bottom-up parser, we are having various type of parsers. What is shift reduce parser? What is LR parser, what is operator precedence parser, all these things will be discussed inside bottom-up parser. And the main categories of bottom-up parser or bottom-up approaches are, the first parser that we have to discuss inside your bottom-up parser is shift reduce parser. Okay, after shift reduce parser, we are going to discuss about LR parsing. Okay, and in LR parsing, we need to discuss simple LR, LALR and CLR. And in shift reduce parsing, we are having one more category of parser that is called as operator precedence. Totally, we need to discuss about 5 different parsers under bottom-up parser category. In this one, first we need to go with shift reduce parser. What do you mean by shift reduce parser and how we are going to verify the input string and the grammar with the help of shift reduce parser. Okay, shift reduce parsing is a main type of bottom-up parser. What it will do, it is going to reduce the input to the starting symbol of the grammar. How it is going to reduce? It is going to verify the input beginning from the leaves, nothing but from the input string. The leaves will be reduced to the starting symbol, nothing but to the root of the tree. For example, here we are having one example, S tends to A, B, and A tends to A, B, C, R, B, and B tends to D. And we need to verify one input called as A, B, B, C, D, E. How we are going to verify this input, whether we are going to get this particular input by using the shift reduce parser or not. Okay, when we are going for the shift reduce parser, here the shift reduce parser, what it is going to do, just we are reducing the input to the starting symbol of the grammar. This reduction is nothing but we need to apply the handle. How? First we need to find out the handle. Okay, if there is any matched handle inside your input representation, immediately we need to reduce the handle to the left hand side of the non-terminal. Like that, we need to follow the number of reductions. At the end, we need to get the starting symbol of the grammar. Here, the handle, it is nothing but it is a handle which is going to be implemented. When you are going for the handle, it is nothing but just we need to take a substring. Here the substring is matching with any of the right hand side of the production. In the we are having set of productions. From the set of production, if any substring is matching the substring from the input string, we are taking the input string. From that particular input string, we need to take a part of string called as your substring. We need to scan it from left hand side to the right hand side. When you are scanning this one, if substring is matching, okay, if substring is matching, then this substring, we are having some left hand side production. Okay, we need to replace this substring with the left hand side production. Here this substring is called as handle, and when you are replacing this substring, it is called as handle pruning. Okay, and by using this method, we are going to reduce the total input to the starting symbol of the grammar. Here we are having the input called as A tends to A, B, C, D, E. Okay, in this one, just we need to scan the input from the left hand side. When you are scanning the input from the left hand side, the first symbol is A. When you observe the given production, in the given set of productions, we don't have A as a handle, nothing but we don't have A as right hand side of the production. Then it is not called as a handle. Here the reduction is not possible. Go for the next input symbol. Just take the next input as B. When you observe this B, here it is a handle because we are having a production called as A tends to B. Then you can reduce, we can apply the reduction step over here, that is A tends to B is a production in such a manner that we can write in place of B, we can write A. Then you are going to get the input string representation as A, B, C, D, E. In this one, when you observe the substring called as A, B, C, here A, B, C, nothing but it is a handle, nothing but it is a right hand side production for a given non-terminal A. Then what you can do here, just we can replace A, B, C with the left hand side non-terminal called as A. Okay, here in the next step, just we are replacing A, B, C with the capital A, then the input string becomes A, D, E. When you observe the next input symbol called as D, here you can apply the reduction because D is a handle. Whenever you find a handle, we can reduce it. That is, B tends to D production is there. I am applying the reduction here. By that, I am getting the input string as A, B, E. Okay, and A, B, E itself, it is a handle, nothing but it is a substring and it is matches as a handle because we are having the right hand side production for S as S tends to A, B. Then it can be reduced to the starting symbol called as S. This is the process to reduce the given input string to the starting symbol of the grammar. And this shift reduce parser or your bottom up parser, it is also called as reverse of rightmost derivation. Here I will show you how it is going to be called as reverse of rightmost derivation. First we will go for the rightmost derivation of the given input, that is we are having the starting symbol of the grammar as S tends to A, B. When we are deriving the given input in rightmost derivation manner, what we need to replace here, the rightmost non-terminal first will be replaced, that is B will be replaced first. And what is the production for B? B tends to D is a production. Then here I am writing A, in place of B I am writing D. Then your substring or your derivation part will becomes A, D, E, that whatever you have replaced. Then in this one, what is the rightmost, and we are having only one non-terminal, that will become rightmost as well as leftmost, that is capital A. In place of capital A, we can write the production as A, B, C. Then you are going to get your string representation like this. In this one, once again, we are having only one non-terminal called as A, that I am replacing with B by using the production A tends to B. Then I am getting the string as A, B, B, C, D. This string we got by using rightmost derivation. When you apply these steps in reverse manner, exactly you will get the shift reduce parser or bottom up parser. That's why bottom up parser is nothing but reverse of rightmost derivation for the given input string. Whatever the steps that you are having, this is the first step, this is the second step, and this is the third step, and this is the fourth step for our bottom up parser. That's why it is called as reverse of rightmost derivation of any input string is called as bottom up parser. And when we are going for the bottom up parser, the first parser is here shift reduce parser. And we need to prove that the given input string is accepted by the parser for the given grammar. Nothing but we can generate a bottom up tree with the help of the given grammar to the input string. Then if you want to generate the given input by using the given parser, we are having stack implementation. Okay, that stack implementation will be done with the help of 4 steps. Okay, 4 operations. Those are called as, the first operation is called as shift operation. What we are doing in shift operation, just we are moving the current input symbol onto the top of the stack. Whatever the current input is there, nothing but we need to read the input from the left hand side to the right hand side. We need to read the input from left to right. From leftmost symbol will become the current input symbol. That symbol we need to move to the top of the stack. That is called as shift action. Next type of operation is called as reduce operation. A reduce, it is nothing but if the top of the stack or handle appears on the stack. Okay, when we are going to see a handle on the stack, then what we have to do, just we need to reduce, we need to apply reduce operation. That handle is replaced with the left hand side non-terminal. Then that is called as reduce operation. Third operation is called as accept. Accept is nothing but after reading the total input, if the top of the stack contains starting symbol of the grammar, then it is called as the action, or the type of the operation is called as accept. The last one is error. A situation where either it cannot perform shift or reduce operation, or some other symbols are left out inside the stack representation, then error message will be given to the user. Now, we'll see how the shift reduce parser will be get implemented for the previous example, that what we have discussed till now, how the input is reduced to the starting symbol of the grammar, that we will discuss with the help of shift reduce parser. Then what we need to take for this shift reduce parser is, first we need to take a stack, followed by what is the input symbol we need to verify, and what type of action or what type of operation that we need to perform the given stack representation, either shift or reduce or accept or error, that we need to write in place of your action place. And what are the contents of stack? By default, to represent the stack, we need to take one symbol inside the stack, that is called as dollar. By default, the top of the stack is dollar, nothing is there. It is also called as bottom representation of the stack. Followed by input. What we need to take input, which type of input we need to verify with the help of your stack application. That input you need to take in place of input. And how you need to write that input? Input followed by end of the input will be represented with the dollar. Dollar is nothing but here right end input marker. Okay, followed by what type of actions that you are going to perform inside your stack representation, that will be represented here. Okay, next, first by default what we are having inside the stack, dollar will be there, followed by input is nothing but what input we need to verify with the help of your stack application, and we don't have any elements inside the stack. Initially we need to shift the current input symbol. What is the current input symbol here? A is the current input symbol that we need to shift onto the stack. Then stack contents become dollar followed by A, because we are shifting A on to the top of the stack. And remaining input symbols are B, B, C, D, E, dollar. And by seeing the top of the stack, do we have any handle inside the stack? No, no handle is present inside the stack. What is the next operation we need to perform? If handle is not there, obviously we need to shift the next input symbol onto the stack. What we have to do? We need to shift B onto the top of the stack. Nothing but previously on top we are having A, on top of A we are pushing B. Now the stack contents becomes AB. Now we need to verify, is it a handle or not? When you observe B, B is a handle. Whenever we find a handle, immediately we need to perform reduce operation. Then how can we perform reduce operation? B is a handle, nothing but it's a right hand side part of the given production. It can be reduced by using left hand side non-terminal. And what we have to do for that? We need to pop the B, and in place of B, what you have to write? We need to push the left hand side non-terminal called as A. That operation is called as reduce operation. Next input symbol is B, C, D, E, dollar. observe the top of the stack or contents of the stack. It is not a handle, then what we have to do, if it is not a handle, we need to shift the next input symbol. What is the next input symbol? B is the next input symbol. That will be shifted onto the stack. Then stack contents becomes B. Then when we observe the stack contents, once again it is not the handle. If it is not the handle, what we have to do? We need to shift the next input symbol. What is the next input symbol? C is the next input symbol that we need to shift onto the stack. Then stack contents become B, C. When you observe this A, B, C, it is a handle. Whenever we find a handle in stack content, immediately we need to perform reduce operation. By using which reduce we can perform it? A tends to ABC is the reduce operation. Okay, nothing but ABC will be reduced by A. In place of ABC, inside the stack we need to write A. That is the stack content. The next stack contents are A followed by A, because in place of ABC, due to the reduce operation, we have inserted A. Then A followed by A is a stack content, and your input is D followed by E followed by $. Then what we have to do is A is a handle? No. If it is not a handle, what we have to do? Next input symbol. What is the next input symbol? D is the next input symbol. Then we need to shift D onto the stack. Then stack becomes D. When we observe the stack, the top of the stack contains D. Here D is a handle, and we need to reduce that particular handle by using the production B tends to D, because we are having one production called as B tends to D. In place of D, it can be written as B. We need to pop B from the stack and we need to insert capital B due to the left hand side non-terminal symbol. Then stack contents becomes B. When we observe the stack contents, it is not a handle. Then what is the current input symbol? E. What we have to do? If it is not a handle, immediately we need to shift the next input symbol onto the stack. Next input symbol is E. E will be shifted onto the stack. Then stack contents become AABE. Okay, AABE is your stack content, $ is your input symbol. And what operation we need to perform in this case? Here when we observe the stack contents itself, it is a handle for the production called as S. Nothing but it is a right hand side production for S. Then immediately we can apply reduce operation. Okay, by applying the reduce operation, the stack contains S, $ followed by S, and input is $. And we reach to the last step, nothing but if stack contains $ followed by S and your current input is $, input is completed and your stack contains only the starting symbol of the grammar, then here we need to write the action as accept. Like this, either we can shift the symbol onto the top of the stack, or the stack content is not a handle, we need to shift. Otherwise, if the stack content is a handle, what we have to do? We need to reduce. Reduce is nothing but rewriting. In place of right hand side production, we need to write left hand side non-terminal. That is called as reduction. Last one is if stack contains only the starting symbol and input is completed indicated by $, then we need to write accept. This is the way how we are going to implement shift reduce parser for bottom up parsing. Okay, and when we are going for the shift reduce parser, if it is simple symbols, terminal symbols called as general identifiers, we can perform this one. If you are having any operator symbols inside your input representation, then we need to follow two rules to implement the shift reduce parser. One is the incoming operator is having more priority than the stack operator. For example, inside the stack plus operator is there. Okay, already inside the stack plus operator is there. Your current input symbol is star. Okay, for example, E plus E is your stack content and current input symbol is star. Okay, in these cases, if current input symbol is star, then here a reduction is possible for the grammar. then there will be a conflict. Either we need to follow shift operation or reduce operation. Whenever we face a conflict called as shift reduce, nothing but either we need to perform shift operation or we need to perform reduce operation. Both will be applicable for these type of cases. In those cases, we need to go for precedence of operators. If stack operator is having less precedence than incoming operator, or incoming operator is having more precedence than stack operator, what we have to do? We need to go for shift operation. Here we need to perform shift operation for this. Okay, in those cases we need to shift the current input symbol onto the stack. Otherwise, already we are having one operator, okay, that is star inside your stack, and current input symbol is plus. In these cases, nothing but current incoming operator is having lower precedence than the existing operator. In these cases, we need to reduce the stack, then we need to shift it. Okay, this is the two different cases we need to follow when we need to evaluate the expressions like this: id plus id star id. We need to implement any input for the given grammar. In these cases, we are having the operator symbols. In case of operator symbols, we need to verify the precedence of operators. Then we need to decide which operator we need to shift and which operator we need to reduce. Okay, these are the two cases. By using these two cases, we can avoid shift reduce conflict. Okay, followed by the next type of parser is called as operator precedence parser. Okay, in operator precedence parsing, we need to verify what type of grammar it is. When we are applying a grammar to the operator precedence parser, it should be compulsory a operator grammar. Operator grammar can be applied to the operator precedence parser. If it is not the operator grammar, then we cannot apply that particular grammar to the operator precedence parser. First, we need to verify whether the given grammar is operator grammar or not. For these verification, we are having two rules. The first one is right hand side of production, there should be no epsilon. When we are writing the production rules for the given production, if any production is having epsilon symbol, then it is not a operator grammar. One more rule is, if two adjacent non-terminals are there for the given grammar, one by one non-terminal is there for the given grammar, then it is not a operator grammar. For example, when you are taking these two productions, okay, E tends to and A tends to. E tends to EAE, or inside the parenthesis E, R minus E, R ID. And A tends to plus R minus R star, division, power, like this we are having for A. When you observe the first production, that is E tends to EAE, right hand side we are having three consecutive non-terminal symbols. In this case, it is not a operator grammar. We can convert this particular rule by replacing A. Okay, when you are replacing A, you are going to get the productions at the right hand side as in place of A, we can write plus, and in place of A, we can write minus. Plus you can write, minus you can write, star we can write, division we can write, and power you can write minus and add. Okay, by this, when we observe this grammar, this is called as operator grammar. And how operator grammar will be applied to the parser, how it is going to generate the parsed representation, these things we will discuss in the next session. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.